we will launch this event. And so, Umar, you will be speaking first. Excellencies, dear delegates, it is a pleasure to welcome you to this side event, to the 2020-50 meetings of the Conference of the Parties to the Basel, Rotterdam and Stockholm Conventions, both here in the room and online. My name is Diana Rizzolio. I'm the coordinator of the Geneva Environment Network, who is present here at the COPs to exhibit what International Geneva does to make visible the invisible. And actually, we are joined here today by colleagues representing various processes of this multilateral Geneva. This event is part of the Geneva Dialogues on Mineral and Metal Resources, organized by the Geneva Environment Network in partnership with the governments of Switzerland and of Senegal, as well as the UNEP Grid Geneva Center, the United Nations Economic Commission for Europe, the International Institute for Sustainable Development, the Intergovernmental Forum on Mining, Minerals, Metals, and Sustainable Development, known as IGF, the Forum on Trade, Environment, and the SDGs, known as TESS, and the World Resource Forum. These dialogues aim to increase the engagement of the international community in Geneva and beyond, in the run-up to and in the margins of various global negotiations and conferences taking place this year, including the one we are attending here at the International Conference Center in Geneva. Sustainable management of minerals has never been so high on the global political agenda. Mineral and metal resources are important for the future, including for the efforts to reduce emissions and fulfill internationally agreed goals, thus ensuring a just transition and enhancing the protection of everyone's human rights, including the right to a clean, healthy, and sustainable environment. This event will discuss the role of the conventions in circular models for mineral and metal resources, including the environmentally sound secondary extraction of minerals and metals from e-waste and waste batteries, their reuse or their life extension. It will highlight how policymakers, business, and other stakeholders are working on policy reforms, new guidances, and standards to take forward the circular digital economy approach, drawing various concrete examples. And I thank in advance our panelists for being here to showcase this. So without further delay, as we still don't have the executive secretary here in the room, we will start by Mr. Oumar Cissé. He was here on my right, because this event is also taking place in the run-up to the 7th session of the United Nations Environment Assembly, who will be taking place in December this year in Nairobi. To co-welcome you to this event, we are joined indeed by Oumar Cissé from Mali, Ministry of Environment, who is the national focal point for this UN Environmental Assembly Resolution 512 on the environmental aspects of minerals and metal management, and he will explain you why we are having also these dialogues in that context. So without further ado, Oumar, over to you.
Thank you, Madam Jara. Dear colleagues, I would like first of all to apologize for my British English. I think that you understand the rest. So I'm delighted to join you today to highlight the link between the implementation of UNEA Resolution 5/12 on the environmental aspect of metals and minerals and the Basel, Rotterdam, and Stockholm Conventions, in particular the Basel Convention. In addition, I would like to draw your attention to the great importance of this resolution for mining countries in general and developing countries in particular, including Mali, my country. With regard to the first aspect concerning the link between the Basel Convention, it is a fact that most mining waste is essentially hazardous waste. For example, ores treated with cyanide in large-scale gold mining and with mercury in small-scale gold mining. The same applies to the large quantity of acid and other industrial chemicals and oils used in factory machinery. The other solid link with the Basel Convention was developed by, had to be developed by the Executive Secretary, who didn't join us, of BRS, and will be developed by the eminent experts here today, representing various multilateral processes of international Geneva. As already mentioned, I would also like to draw the attention of this august assembly to the urgent need to take coordinated action on a global scale to deal with the environmental aspect of metals and minerals to ensure their sustainability and to safeguard the global environment. As justification, I can cite a very simple example of sand and gravel, which together constitute the world's most exploited natural resource after water, to the tune of 50 billion tons per year. This could be used to build a wall 27-meter high and 27-meter wide that would encircle the planet. Just look around you. This building, the roads outside, the windows, all contain this basic material. Well, these days, quality sand and gravel are on the way out. Let's move on to metals, particularly precious metals, gold par excellence, and strategic metals such as lithium for electric batteries and cobalt. The exploitation of these metals and of gold in particular has made the environmental headlines in recent years. In this respect, we welcome implementation of Article 7 of Minamata Convention on Mercury and its Annex C, dealing with the use of mercury in artisanal gold mining and the pollution of soil, and was generated with the support of the GEF as a final mechanism. All these metals and minerals bring happiness to humankind, but also cause environmental disaster when they are mined. If need to be corrected through generally accepted and shared global measures. Effort to harmonize legislation, create digital hubs for sharing experience, transfer technology, and other types of capacity building, training, and experience sharing must be developed in the first instance at UNEP and UNEA level, and subsequently through the drafting of a voluntary and/or binding legal instrument on a global scale. The message we would like to convey is that the environmental sustainability of metals and minerals throughout their life cycle, including minerals essential to the energy transition, is an issue of global importance that must be addressed at all levels, including the international level. Initiatives are underway through the appointment of national focal points for the implementation of Resolution 5/12, the holding of regional workshops and global meeting in September 2023 in Geneva under the auspices of UNEP. The sixth session of the UN Environment Assembly kept the pursuit of the resolution afloat, and the trend is toward increased ambition during UNEA 7. I thank you.
Thank you, Mr. Cisse, to make the effort to speak in English and to make the links with what is happening at the United Nations Environment Assembly. So those who are joining us online in the chat have been receiving links to the various processes and documents that we will be mentioning here. For those who are in the room, there is a link on almost all the slides. That's where you will find the presentations of today's event and many of the documents that will be mentioned here. As Mr. Payet is not yet here, I recommend we move on with this event. And it's now my pleasure to invite a colleague to set the scene for today's discussion. So we have invited the United Nations Trade and Development to join us to present the Digital Economy Report 2024, a report that they released last year, which emphasizes the significant dependence of digital technology and infrastructure on raw materials, as well as the escalating environmental impact caused by the growing production and disposal of devices, coupled with increasing demands for water and energy resources. As you will hear, it also stresses that developing countries bear the brunt of the environmental costs of digitalizations while reaping fewer benefits. It's a very interesting report, and we are delighted to be joined by Pilar Fajarnes, who is an Economic Affairs Officer at the UN Trade and Development, to present the findings of the more relevant chapters of this report that she co-authored for this discussion that we are having here. So without further ado, you have the floor.
Okay. Thank you, Diana. Thank you to the organizers for inviting UNTAD to share the findings of the report. And hello to everybody. Thank you for being here. While the Digital Economy Report is one of the flagship publications of UNTAD, and it has focused normally because of the mandate of UNTAD, which is trade and development, mostly on socioeconomic benefits of digitalization. But this year we've found that it was important to add another dimension to the relationship between digitalization and inclusive development, which is really environmental sustainability, because we are seeing that global challenges are more and more interconnected. We need to have a proper view or proper understanding of the linkages between the different global challenges. So what we highlight with the findings is that development gains are really in looking at this relationship between development, environmental sustainability, and digitalization. There is a situation of unequal ecological exchange. So we see that the environmental impacts are there are higher divides in environmental impacts, as we can see from the unequal impacts of climate change in different countries, where the higher impacts go to those countries where the temperatures are higher, and wealthier countries that are in cooler situations, they can have the benefits. Also, it is vulnerable populations that are the ones that are hit harder, and these are marginalized groups in different that are suffering the main losses from extreme weather. If we look at what is digitalization itself, the negative impacts that come from digitalization, from the production of digital devices that we have focused on mineral production, mineral extraction, and the generated waste, they are often affecting regions that are far from the core of the consumption countries. So it's mainly developing countries where the production of minerals is concentrated. And also, the final point we are highlighting is that because of digital divides, also developing countries are less able to afford and harnessing digitalization to mitigate environmental impacts. So what we highlight is that these three dimensions of the device, in terms of development, environmental sustainability, and digitalization, need to be seen in a holistic way and need to be addressed holistically. Okay. Well, you see that I may know about impacts of digitalization, but I'm not so good with IT. Okay, I hope it stops there. So we have structured the report by looking at the environmental impacts of digitalization along the whole life cycle. It is the three main stages is production, use, and end of life. From the point of view of this meeting, the minerals dimension comes mainly in the production stage, and the end of life stage and the waste related to digitalization or the approach to circularity. But we can see and we can highlight also that the use stage is also having an influence on that. And we can think in that, for example, now with the boom in AI, there is a boom in data centers, and this implies an impact in construction, an impact in the demand for devices that would be really the first stage of production, but it really has an impact. And also there is an expectation of or prospects for e-waste are also coming very high. We are looking at the direct effects, negative effects on the part of natural resource depletion, energy use, water use, greenhouse gas emissions, pollution and waste. And this is really what is called the environmental footprint of ICTs, information and communication technologies. Then there are indirect effects, but this goes beyond the scope of the report. So the idea of the report is to focus on reducing the environmental impacts of digitalization. Okay, so starting with the production phase, I have to say that the logo or the motto of that you said about making visible the invisible, I like it very much because it's very, very similar to the point of departure that we came from this stage, saying that we think about digital in terms of virtual, intangible, the cloud, like something that is dematerialization, but it's not true. I mean, we don't see how much material it means all this digitalization progress. And then this is what we have focused on, that there is a huge impact, intensity of materials. There are different materials in the electronic equipment, and it includes plastics, ceramics, but we have focused on minerals because it's really, from the perspective of development, is really the one that had more interest for UNCTAD. This is also, I mean, we can see the intensity, for example, in the case of a PC that maybe weight 2 kilos, it involves moving 800 kilos of material. What is also important from the materiality perspective is that the devices are becoming more and more complex, and they include more elements. For example, in the case of phones, in 1960, there were 10 elements that increased to 1990, 27, and a smartphone in 21 included 63 elements. And they are also in small quantities, but they are very blended, which makes the recycling very complicated because we have to start thinking in the whole of the cycle. So this is the issue. And also another aspect to highlight is that now there is a lot of attention, as you mentioned, to critical minerals because of the decarbonization in relation to energy, renewable energies, electric vehicles, but the demand from digital technologies is also important. So in a way, there is a competition, and all this demand, increased demand, implies that there is really, there are projections for this demand to increase significantly. And one of the issues that we highlighted here is this, that the minerals that are used for digital technologies are essentially the same that for low carbon technologies. And this was done by looking at the different critical mineral list that countries are elaborating in these years. The demand for minerals is mainly due to the progressing demand of ICT and internet use. We have some illustration here. We can see in the different regions of the world the change from 2018 to 2023. And also the figure on the left shows the divide, what is the difference of consumption of ICT in developed countries and developing countries. We can see, for example, in North America in 2023, it was 13.4, the number of devices per capita, and it compares with the Middle East and Africa of 1.5. That we will see later that also leads to device in the generation of e-waste. And also we can see a very rapid progress in the use of data, in the mobile data traffic. Excuse me, but we move to the situation that the implications, the geopolitical implications that this high demand creates. On one hand, we have that, as I mentioned, that the production and extraction is very concentrated in a number of countries, in a few countries, and mostly in developing countries. And you have some numbers here. For example, cobalt, we know about the Democratic Republic of the Congo, lithium, the lithium triangle in Latin America, or here we have manganese, that's about 60% in Gabon and South Africa. But what we have also is that most of the processing of these minerals, these developing countries tend to export these minerals in raw form, and most of the processing is taking place now in China and also in developed countries. And because of this increasing demand for critical minerals, developed countries are having a strategic interest in having access to these, the supplies, to ensure supplies for different reasons, including security. And they are having industrial policies to ensure this supply. But this is also leading to problems of having a risk of expanded environmental footprint through overcapacity or holding of these minerals. This is also, in general, this is leading to pressures over supply in the sense of expanding the mining frontier. And it is, you know, suffering most in developing countries. And this is also leading to the need to rethink modes of production and consumption, because this expanding of the mining frontier is going into, I mean, we can think about the planet, about, for example, the Amazon, illegal mining, and many other issues like that, of how the environmental and social impact of mining is affecting the planet, but also there are moves to move to deep seabed mining, which actually is in discussion, and it is really, or to move to mining in the space, to mining asteroids or to mining the moon. And in both of these cases, these are global commons. They are not well regulated, and the environmental impacts are not well known. And there are a lot of concerns about the attempts to try to move mining to these areas. So, in general, for solving these issues, the policy approach is from the focus of UNCTAD and development. We highlight the point that there is a need to change the extractive narrative of the past, where developing countries were not able to benefit from the production of the raw materials, so they should be able to add value domestically and to reduce commodity dependence, to reverse this unequal ecological exchange, and to ensure that environmental and social impacts are minimized. So there should be a policy approach addressing these imbalances. Regional cooperation can help in that sense, and there is also the need for international cooperation for sustainable sourcing practices and balancing all the needs of stakeholders so that these countries can leverage the mineral wealth for development, achieving diversification across the value chain and through a structural transformation. If we move to the end of life of the life cycle of digitalization, the clear trend is that the waste related to digitalization is growing, but it has uneven regional implications. One key aspect is that this waste has a dual nature. It is, on one hand, a hazardous materials, as you well know in the context of the Basel Convention, but it also has valuable parts that can be a source of development. The regional disparities that we see and that are mirroring digital device, we see that the increase, for example, this is one issue with the statistics. We have worked in the elaboration of this report with UNITAR, which is doing a lot of work in the global partnerships of e-waste statistics. But the definition of digitalization-related waste is a kind of tricky in a way. So we have taken the two categories that they have that would be more focused for electronics, because it's electronics and electrics, what they have. But also we can think that the definition is a moving target, because, for example, in e-waste, they don't include batteries. We can think that the Internet of Things is going to make many electric equipment, like, let's say, a washing machine, electronic. Then they don't include the waste in the space, and satellites are very important for the purposes of digitalization. Electric vehicles, we can also consider that they are becoming more and more electronic. Actually, vehicles are more and more electronic than mechanics in a way. And also they are in their context, they are also starting looking at the waste coming from decarbonization, like from solar panels. So we have to think about this in an open way. Also, the statistics are very, these include many kind of illegal trade or illegal exchanges, and much of the waste is not documented. So the statistics are a very good contribution, but they have also to be taken with some caution in a way. So from these statistics, we have taken the waste from screen monitors and small IT equipment, which increased between 2010 and 2022 by 30%. And we can see there the differences between digitalization-related waste per capita between developed countries. We can see that they were generating 3.25 per capita in developed countries, and it compares with 0.21 in LDCs, one person. And we see that the formal waste collection rates are very low. Still, even in developed countries, they are less than half. Globally is 1/4, and in developing countries is just 7.5%. The challenges, which are quite general, but they are more intensified in developing countries, is the limited recording and documenting of waste flows, the lack of formal collection systems, that only 1 in 4 countries have relevant waste management legislation, and the insufficient collection and recycling infrastructure. This growth of digitalization-related waste is set to continue over the next years for many of the trends in rapid progress of digitalization. The main drivers are increased consumption, the short lifespan of devices, the declining prices, the low awareness of consumers of the implication of this waste, the fact that we continue in a linear production model, or the limited repair options. We know about the issues of program obsolescence. That is starting to move in a way, but it has been banned in France and Quebec, but it continues to be a problem. And we have demands from civil society to address this situation in different directions. So laws against this obsolescence, in durability, in lifetime of labeling, on repairs, and on consumer education and information. From the perspective of UNCTAD and also regarding the Basel Convention, it is fundamental to look at the trends. Again, here statistics remain a problem. This is the data from the Global Transboundary Flows Monitor from UNITAR in 2022, and is really highlighting that it is important that there is really an international flow, but while there is some movements that are legal under the Basel Convention, there are a number of uncontrolled e-waste use electrical equipment, electrical and electronic equipment. In this case, we had to look at e-waste because it's not possible to disaggregate the international flows. But, and this move from developed to developing countries or inside developed countries from the highest income regions to the lowest income regions. And on the other hand, we can see that in the case of printed circuit boards, which are the, one of the most valuable parts of the electronic waste, the flow goes from developing to developed countries, where most of the few recycling facilities are there, which means, again, developing countries are in the lower value parts of the e-waste value chain. Again, we are finding a pattern of unequal ecological exchange, where the value is in developed countries, but the environmental impacts are in developing countries. Because, and the problem is that the flows of these e-waste to developing countries faces the problem that these countries are even less prepared to handle these flows in an environmentally sustainable manner. The important, sorry.
Click on the.
Okay, I don't know where I click, sorry. We see here the waste hierarchy, and certainly the issue is to focus on the reduction part, because the idea is that we need to reduce waste. Very often when people talk about circularity, they focus on recycling. Recycling is important, but it should be the third best. It should be first thinking in reducing and reusing the equipment. Then what I would like to highlight is that addressing all these issues is a joint responsibility of all stakeholders. It's about production, it's about consumption, and it's about policies. So we have focused, or we have looked in the context of the SDG. The SDG 12 is the one that matters in this context, and it's about responsible production and consumption. But we really see that sustainability requires consumption in the digital economy that needs to be rethought in the context of digital sufficiency. This is aiming to deliver human well-being within planetary boundaries, where we have illustrated this with the using the donut economy from Kate Rathbone. So we are really thinking that there is a need to have a level of sustainable digitalization. Below this social floor, there is insufficient digitalization, and that is socially unsustainable, and this, that is mainly developing countries, should go up in digitalization. But above the environmental ceiling, this is unsustainable digitalization, and this is where mostly developed countries should go towards less overconsumption and moving towards the center of sustainable digitalization. So we see that one of the ways forward is to really look at the digital economy in the terms of circularity, to make a circular economy by design, to foster environmental sustainability. So it is important to move from waste to resources and value. And we see that there is a need to, basically the objective would be to minimize disposal. And then the idea is that, yes, with all the increase in demand, we need to have more primary supply, so more extraction of minerals. But we need to also increase secondary supply from recycling, or what is also called urban mining, to recover resources. And then to reduce consumption is fundamental through remanufacturing, refurbishing, redistribution and reusing and repair. All this creates also opportunities for developing countries because it has opportunities for value addition and job creation. It can reduce digital divides because it can generate activities also for repair, refurbishing and second-hand markets that may be more affordable, and it can reduce resource use and waste, and we see an important role for regional cooperation. In this schematic way of the circular digital economy, we would see that the first stage should be certainly what we see important is the making the circularity by design. So, and it needs also to build adaptive and resilient infrastructure, to use low carbon energy, then reducing overconsumption, prioritizing activities like repair, reuse, refurbishing, and recycling that would allow recovery of resources, and certainly boosting opportunities for business growth and job creation. Sorry. So this requires a new policy mindset to address this challenge with innovative approaches, is new business models and policy strategies to maximize digitalization, the positive impacts, and reducing or minimizing the negatives. That would reduce consumption, help cut carbon emissions, and leverage digitalization-related waste to transform waste in recovery and in activities for the circular economy. For addressing this double bind that we see in developing countries, developed countries that are capturing most of the benefits should take a common, or the world, a common but differentiated responsibilities approach, which implies that developed countries need to take the main responsibility towards shifting to an inclusive and sustainable digital future, and they need to provide support to developing countries in building the capacities to harness digitalization in an environmentally sustainable manner. And here I would like to highlight one of the needs that we see in capacity building is really in enhancing monitoring and enforcement of the Basel Convention of the situation, so that a global digital economy that works for inclusive and sustainable development can be harnessed. In the global approach, we see the need for multilateralism and cross-sector dialogue, multi-stakeholderism, and the need to align digitalization and environmental policies. And we also highlight from in our call for policies in this context the need to track the environmental footprint of the ICT sector in a comprehensive manner. Finally, the action that is needed is at both national and international level, integrating what is digital, economic, or socioeconomic and environmental sustainability strategies, focus on reducing emissions, water use, waste, and also using digital solutions in the sense that we can also think that digitalization can help environmental sustainability, but always looking at digitalization in a way that it is environmentally sustainable. And at the international level, there is a need to consider the diverse needs and priorities of the countries and the opportunities that can be generated. and the importance of the support of developing country, of development partners. And there are already ongoing, to highlight ongoing policy dialogues. There was the Summit for the Future and the resulting Global Digital Compact that already integrated this need of looking at the interface between digitalization and environmental sustainability. Then we have this summer the 20 years of the World Summit of the Information Society. We can do it in the 2030 Agenda for Sustainable Development. This is also a clear example of looking at this interface. And also I would like to highlight or to bring to your attention that next week in UNCTAD we are having the Intergovernmental Group of Experts on E-commerce and the Digital Economy from Monday to Wednesday, where we will be discussing these topics. And I would like to leave it like this with the quote, if I can be able, from our Secretary General that says, "Together we can harness the benefits of digitalization while closing the digital divide and protecting our planet." Thank you very much.
Thank you very much, Pilar, for bringing here the findings of this report. And before we move on with the agenda, maybe we could take 2-3 questions on the report, if you have some burning questions. There were a few online. And before bringing them, I just wanted to making the visible the invisible that you mentioned is actually the theme also of these CUPs. So first question, is the report available in other UN languages?
Unfortunately, because of budget limitations, this report was usually in English, Spanish, and French, but this year is not being translated.
Okay.
It's a pity.
Okay, thank you. There were a few questions online on the data used for the report, and I will take a question here in the room. The data that you presented in your first slides, they were asking if there were data also from the US and the EU included there. Somebody seemed to have some doubts online. And then there was another question on a colleague from UNEC was asking if the possible impacts of the quantum computing, the photonic computing, and other new technologies are considered in this analysis. And while you think about what you are going to reply us, I will take the question from this lady. If you could introduce yourself.
Thank you. Good afternoon, ladies and gentlemen. I'm Caroline Aguti, and I come from the Republic of Uganda, part of Africa, and I work for the energy and extractive sector. Thank you very much for the informative report. We have enjoyed every bit of your presentation. Yes, so going forward, are there some guidance notes? How are we actually going to implement the recommendations of this study? Are there some steps going forward on the actual implementation? Thank you.
Any other question? Any other question? No, so Pilar.
Well, on the statistics, we are using the best available statistics in all the topics. In general, is our motto. And yes, the US and the Europe, they are included. So I don't know which are, but I mean, I wouldn't mind to have a personal and elaborate if the person wants to contact personally. So that's okay. On the uses, I understand if we are factoring in the possible progress in technologies, something like that. So actually in chapter 2, we are having a long discussion on what is the evolution of technologies, on the different technologies, also over the value chain. So from connectivity, the using or the question of submarine cables, the question of, and then the use, we go for the use of AI and how it is expected to evolve. But it is true in general in digitalization, the data are tricky. So we, again, do the best we can with the data we have, with the data that are available. And on the implementation, I would like to highlight in here, well, the way we do here in the report and in UNCTAD is more an orientation for the countries, but then there is a need of lot of debate. So the kind of research we do is to inform policy discussions among developing countries and with developed countries. But I have to say that we have there, in the policy recommendations, we have a detailed list on how to implement the kind of things that could be needed. So I would encourage you to go to the report and look. Of course, in 15 minutes here, I couldn't really go in much detail, but it's a question of there is a need to agree on definitions, to agree on standards, to increase capacity building in the sense of better infrastructure for recycling or improve legislation, these kind of things. So
Thank you, Pilar. Indeed, that's also why we have invited you here and in this series also to bring these elements to who is working on these topics. So let's move on with the agenda. We have invited experts from various processes ongoing in International Geneva to highlight how policymakers, business and other stakeholders are working on policy reforms, new guidances and standards to address the issues that we are discussing. So we will start by the world of work with our colleagues from the International Labour Organization who will be speaking about the e-waste circular value chain, both from the formal and informal workers' perspective. We are joined by Reina Kuwashima and Christoph Ernst, so bringing here the labor dimension of the e-waste agenda. You have the floor.
Good afternoon, everyone, and thank you for inviting us. My name is Reina Kuwashima from the ILO Employment in Investment Branch. Today, Christoph and I will share insights on e-waste and its employment dimension. I will first provide an overview of the labor aspects related to e-waste, and then Christoph will continue with more technical perspectives. So e-waste is the fastest growing waste stream globally, and it contains many valuable materials, including critical minerals. And this means it's not only an environmental issue, but it's also an economic opportunity. But unfortunately, up to 80% of e-waste is exported to developing countries, often illegally. And in many cases, these countries lack proper legislation or enforcement, which makes it even harder to manage safely. And as a result, e-waste is often discarded with general waste. This causes serious environmental and health impacts. It's also important to remember that e-waste is hazardous, costly, and very complex to treat due to the presence of toxic substances. And lastly, most e-waste is not recycled by formal systems, but by informal workers who often operate in unsafe conditions without proper protection. And in the rest of our presentation, we will focus on this labor aspect and the opportunities for decent work in e-waste. So this slide shows how e-waste flows through the value chain and how much of it is managed informally. In 2022, 62 billion kilo of e-waste were generated globally, but only 22% was formally recycled. And the remaining 78% was either handled by informal workers or recycled outside of formal systems or disposed of as waste. And this includes unsafe dismantling or burning and chemical exposure, and this is leading to environmental damage and serious health risks. In order to address this, we've got two solutions. And the first one is to create more formal employment opportunities to ensure safer and regulated jobs. And second one is to improve working conditions for informal workers that are already there through better regulations, skills training, and social protection. And these 2 points will be the focus on my following slides. So one of the biggest opportunities in e-waste management is its job creation. So manual sorting, dismantling, repair, and refurbishment are labor-intensive process. And they can create more jobs compared to mechanized systems. So for example, manual recycling can create up to 200 jobs per 1,000 tons of e-waste. But in contrast, mechanized recycling only creates 0.5 jobs per 1,000 tons. This demonstrates that prioritizing labor-intensive processes like dismantling can significantly boost employment. And formal e-waste management can also promote inclusive employment opportunities. And these jobs often require low entry-level skills, which makes them accessible to many people. And in particular, dismantling work that require focus can be more suited for people with intellectual disabilities. So investing in formal e-waste systems not only supports the environment, but also creates decent and inclusive work. And while we work toward formalizing the e-waste sector in the long term, improving conditions for informal e-waste worker is much more urgent priority. So let me start with the economic side. By helping workers develop their skills and become more productive, we can support their transition into higher value recycling work. And this allows them to earn more and take part in safer and more advanced part of the value chain. And next, we need to focus on improving their actual working conditions. Many informal workers are exposed to dangerous environments. So it's really important to ensure that proper occupational safety and health standards are in place and that they are really followed. And access to social protection like healthcare or income support is also critical. And we need to make sure that their labor rights are also respected. That includes giving them a voice through representation in trade unions and other collective processes. And these steps can help bring informal workers into more secure and decent work while supporting the goals for circular economy. With that, I will now hand it over to Christoph, who will go into more detail about occupational safety and health.
Into the nitty-gritty, thank you, of the quality of the job, especially on the occupational safety and health side. We also have a special report. You see the source where you can see how to improve occupational safety and health in e-waste. So what are the issues related to occupational safety and health? E-waste is often related to carry also heavy waste materials. So that's also affecting, for example, the bag. It's often, workers are often exposed to heat, to dust, and they treat with hazardous chemicals. Especially also the transport of this toxic material is often creating some problems, but also some for the workers, but also some bottlenecks to transport the material. They are often working in narrow workplaces in strenuous postures. Here's, for example, a way of how to improve it. We also have some concrete examples how to improve it in the workplace. There's often unsafe use of electricity and machinery, and they often work also long and irregular working hours, people who work on e-waste. There are health risks also related to family members when dismantling work at home, because often this kind of e-waste in the informal economy is done at home, and so there are also families, kids running around, etc. Let's be a little bit concrete and look at a specific situation, also how to handle with this. So we had the example of Chintan, which is an Indian NGO supporting informal e-waste workers in this local area. So what are the different activities they started? First, they build up partnerships with the key stakeholders. For example, there's the Silicon Valley Toxic Coalition. Then they also they also created some partnerships with companies like Nokia, and also developing cooperation partners like ShareSet. So first of all, it's very important to understand and map the workforce, to understand a little bit about the workforce, to collect the data on informal workers, because it's not there, about their skills and about their working conditions. And then also look into the value chain and to analyze the dynamics of the e-waste in the value chain. Then the second part is very important. Then based on this information, how can we organize better the informal sector? So it's often a question also to register the informal workers in associations like the Safai Sena, because that could be a channel to provide support to them, to provide social protection, to provide training on OSH, on different skills they need, but also help them to develop business plans and collection centers also on the enterprise side. Then another important aspect is advocacy for policy changes. So that's at higher level, so to participate in discussions on India's e-waste legislation, which is very important, how to design the legislation to work on this, and also to promote the formalization of informal workers, that these could transit from the informal to the formal work. And also raise awareness and rethink the extended producer responsibility, to highlight the value of the e-waste, how important it is. There's a lot of important material, it has a lot of value, as we have seen, and separate the collection. And re-evaluate also the EPR to ensure fair pricing for informal workers, that they're treated also equally to the formal workers. So the idea was here to unlock the job opportunities through formalization. This is one example. There we also have a couple of other examples, just to highlight a little bit what can be done on the employment side. To summarize a little bit what are our key recommendations. Oops. Go back. Sometimes we go too fast, but very sensitive. No, I'm too far. Yes, I'm too far. First of all, it's a question of technology. Yeah. So when we talk about using the recycling technology, what is the appropriate technology suitable for the situation? For example, if you have some countries, I work in Argentina, and then we had a project with Ireland, which is mostly formal. In Argentina, there are lots of opportunities also for informal workers, for young workers to work on this. So what is the use of high tech, the capital intensity, compared also to develop more safer and cheaper methods by simply processing methods for the informal sector. It's also what can you do at the informal sector? How far can you do? How can you extract it? Repair work, yes. Redesign work, no. So that's a question also to find the right technology for the right people. Another aspect is also to work on the regulations and the incentives to have the right balance between effective regulations, which could also be combined with financial initiatives to encourage informal recyclers, but also to adopt safe and non-destructive practices. So also to regulate a little bit the informal work, and also provide support for informal recyclers through financial incentives, and also to create demand for informal recyclers to deliver recovered parts to central collection sites by the government, but that could also be by big companies, multinational companies, who then have to retake according to the extended producer responsibilities, and to bring the different actors together, but also guarantee the quality of it. So also it's very important to, in this context, to address the social inequities. So we have to find multidisciplinary solutions, not just technical measures, but also other solutions to tackle social inequities in the e-waste business. E-waste business is when we talk about circular economy, one which has more value and that provides new opportunities, and we have to see how these opportunities also help, for example, to include young people in the labor market, informal workers. Related to this is also the question of the policy and the product design improvements. A lot has to do with the EPR, how in some countries they don't have it, how to design it, how to create it. But the other major issue is also how to enforce EPR legislation and how to redesign products that you can, that they become green, that you can build in recycling, that you can use the material later on, and that it could be also upgradable. So I think this is in a nutshell from our side. So please, if you have any questions, we are here.
Thank you. Thank you very much, Heina and Christophe, for this presentation, making links on what's happening with other ministries, trying to improve the conditions of who is working with this e-waste. And this topic is important because actually it has been raised in various side events that we have organized here with NGOs such as the Basel Action Network and others. So now let's move to a topic that is closer to who follows these negotiations. We are continuing our discussion with two experts from the Basel Convention Partnership for Action on Challenges relating to e-waste, known as PACE2, which has been supporting stakeholders in fostering best practices to strengthen the environmental sound management of various e-waste streams. We have here with us Leila Devia, who many of you know. She's the co-chair of PACE2 and a senior advisor to the Basel Convention Regional Center in Argentina. And we are also joined by Federico Zanotti from the Bureau of the International Recycling, who is also the co-chair of PACE2, Project Group 2. And they will introduce us to PACE and the guidance that they have been working on, also mainly for those who are joining online who might not be familiar with what's going on this space. And may I ask you, Christophe, to switch off your mic as I'm now giving them the floor. So Ms. Devia, Mr. Zanotti, you have the floor.
Thank you for this. Where is the presentation? Okay, well, thank you very much for this invitation. I would like to present who we are. PACE2 is the Basel Convention, revised the terms of reference to add new e-waste types and adopted a new name for the partnership. This partnership is a partnership that was worked like the name PACE1 in past years. So the decision of the PACE2 was, thank you very much, the decision of PACE2 is 1522 and the decision 2018, which is the membership. The membership is one Basel on Stockholm Regional Centers. This is a particularity of PACE2. PACE1 is commanded by parties and PACE2 by regional centers. 23 countries representative. Also, we work with private sector. Federico belongs to the private sector. 10 international organizations, 3 NGO, 2 development agencies, funds, and 9 observers. The terms of reference that is approved for the COP is goal, scope, and overall task. As said yesterday when I intervened on the plenary to talk about who are our working and how is now, is an enlarged scope. In PACE1, we focus on mobile phones and computers and equipment. But now we are focus on used and waste. TV screens, CRTs, video and audio equipment. And for refrigerators, cooling and heating, there is develop another side event in parallel for the phase 2 that is aligning the Montreal Protocol with the phase 2 in the case of cooling and heating, which is a draft program of work that we are doing. First of all, dissemination of activities. We made many activities, pilot projects. We finalized 7 pilot projects and 3 development of guidance of environmental sound management of new e-waste types and on the repair and refurbishment. Sorry. This is general guidance. So the most important things to remember is there is one partnership 1 and partnership 2, and the partnership 2 is very important because it's a new enlarged scope, and these 2 guidelines is very important for the parties. There are the general guidance document on use and waste TV screens, audio and video equipment. Well, general guidance of refrigerators. And I would like also to present it in, sorry, the page 2. Now it's the most important thing, because it's a real product that we have, is not only to guidance. We completed in 2000 and this year 7 projects. 1 in Africa, repair and recycling, training of national authorities, preliminary action on enhanced ESM, guidance on recycling, also in Trinidad Tobago, collection policies for mobile telephones, so on. And in Greenland, in my region, we are training package on ULAB. So I think that is not only to guidance, to discuss and to continue. It's important that we develop 7 projects in developing countries. So thank you very much. And I gave the floor to Federico to explain the guideline.
And Federico, if you could stick to the time, because we have one more speaker and a room for contact group.
I'll try to be quick. Thank you, Laila, and hello everyone. Thank you for being here with us. So I'm Federico Zanotti, Trade and Environment Policy Officer at the Bureau of International Recycling, and I also serve as co-chair of the Basel Convention Phase 2 Project Group 2, which is mandated to develop this guidance document on the repair, refurbishment, and ESM of TV screens, audio and video equipment. And my role is to bring the industry expertise into this process. So today I'll give you a quick overview of the key objectives of this document, and I will also highlight some of the key challenges that the industry is facing in recovering metals from electronics. Let's start with some key numbers. So the volume of e-waste generated today is already massive, and it's expected to more than double in the next 25 years. And these devices are a rich source of valuable metals. In 2022 alone, e-waste contain over 31 billion kilograms of metals. And if these metals were properly recovered, they could meet, in many cases, the current demand for clean technologies. So I think this already underlines the strategic importance of enhancing electronics recycling. But what is the current status of metal recycling from electronics? Well, rates are fairly good for metals like copper, aluminum, and nickel, and even for precious metals like gold. However, the recovery rates drop significantly for cobalt and zinc, and even more for rare earth elements, where we are below 1%. So I think this last number is quite critical and alarming, considering that rare metals are essentials for the energy transition. So how do we improve these numbers? Well, technology is already making progresses, but that's not enough, and we need to look at policy frameworks and regulatory support as well. And this is exactly where the Basel Convention and our document comes in. So the Phase 2 guidance document aims to help countries build the technical capacity to recycle complex electronic equipment in an environmentally sound manner. And it does so by gathering best practices from around the world, covering the full ESM value chain. So from collection, transport, dismantling, mechanical and manual separations until the downstream recycling of the different components found in these devices. And this guidance wants to be practical, and it is designed to support ESM at every stage. It also follows the waste hierarchy, a core principle of the Basel Convention. So the first part focuses on repair and refurbishment, giving devices a second life, while the second part deals with the recycling part. And the work on the guidance will continue after this COP, and we're still gathering input from governments and the industry. So I invite you all to engage in this process and get involved. But before concluding my presentation, I want to present two real-life case studies that illustrate the technical and policy challenges in recovering critical metal from these devices. And I hope this will serve to raise awareness around the complexity surrounding these practices and the need for greater cooperations. So I will focus on TV screens and their components, which are central to the guidance. So the first component is a liquid crystal display, or LCD screen. So these screens contain indium, a rare metal essential for clean technologies and which is very scarce. And today, about 75% of indium produced globally ends up in LCDs, making the recycling essential. And here in the slide, you can see the basic structure of a flat panel display. So there is a plastic case at the back and a liquid crystal layer sandwiched between two glass panels. And the indium is to be found in this liquid crystal layer. And I think this already says a lot about the complexity of recovering it. So which are the major challenges? First, low concentration. So indium is highly dispersed and found in very small amounts in the liquid layer. So inevitably, large volumes of these liquid molecules are needed to make recovery profitable. And this will require financial incentives for recyclers to be able to operate with margins. Then complex design. LCDs are made of tightly bounded layers, often sealed with heat sealing, and this makes mechanical separation difficult and risky. And finally, hazardous substances. So older LCDs may still contain mercury-based backlights, and mercury is hazardous, and obviously this adds safety and regulatory compliance issues, making indium recovery often non-viable. So I think this case shows the need to engage manufacturers and speak more and more about eco-design. The second component I pick is printed circuit board. They are the most valuable fraction in TV screens, as they can contain over 40 different metals. But again, there are significant challenges to their recovery. First, many PCBs contain hazardous substances like heavy metals and flame retardants, which make, again, dismantling and processing costly and challenging. But more importantly, the composition of PCB is highly complex, requiring advanced mechanical and chemical processes to recover the metals. And these processes are available only at a limited number of integrated smelter facilities. And only such facilities can recover all the different metals efficiently and, more importantly, under environmentally sound conditions. And this brings me to my final point, that is, if we want to enhance circularity of critical metals, then the safe mobility of resources is essential. And looking at our case, PCBs must be able to reach those facilities that can process them properly and in an environmentally sound manner. And this is where the Basel Convention comes in again, which is work on improving and digitizing the Convention's trade control mechanism to make legal shipments for recycling faster, safer, and more efficient. So we can see that the challenges are here, but through cooperation within the Basel Convention framework, we can turn these challenges into practical opportunities. To conclude, I invite you all to learn more about the work of PACE2 and our guidance document. You can find more information at the link on the slide, and you're very welcome to participate with your expertise. Thank you very much for your attention.
Thank you very much, Leila and Federico. And now the next expert we have invited to join us is also from the private sector, Mr. Paulo Gemma, who is joining us online. He's a senior expert for the Europe branch of Huawei Digital Power. He's working in the Working Party 2.5. He's even the chair of this ITU Study Group 5, Environment, EMF, Climate Action and Circular Economy, a lot of acronyms. And Mr. Gemma will be speaking on the International Communication Union standards and recommendations to support the implementation of proper e-waste management and rare metal recycling. Mr. Gemma, you have the floor.
Thank you to invite me. You can hear me?
Yes, we can. And now we have you on screen also.
Yeah, okay. And the slide I need to share? Okay, thank you. If you go to the next, okay, ITUT is a standard body. We are one of the three international standardization body with ISO and IC. And just to give, as we speak about policy and standard, what is a standard? A standard is a way to define objective priority, share best practice, provide requirement specification for, in this case, for e-waste as to recovered material. If we speak about the circular economy, we need standard to circular economy design, for the e-design, for the qualification of material, especially the recycled material, some measure how to put the circular economy, and on inform the policy on what is possible to do. If we go to the next, please, which is the role of a standards policy. Standards developed normally as a consensus, so involving different stakeholders from telecommunication, operator, industry. This is the case of ITU, regulators, academia, research center, is open communication. Our standard is available free of charge, so anyone can download our standard without any issue. And our idea is the rule of our standard is to support the administration and government and industry in the implementation of the standard. We are not writing directly the law or the rule, but we can give a tool to the administration that they can use in their act, in their law, to refer to some technical point. We are making technical standard, and okay, if they want to have a standard on e-waste management, on circular economy, on the percentage of recycling material, is something that can be found in a standard. So this is this is our rule on standard. If you can move to the next, we can see which is ITU. ITU, okay, is partly a worldwide organization. We are more than 194 member states, administration, 700 private sector organizations inside us, and around 150 academia or more. And also a lot of partnership with organizations like Basel Convention and so on, in which we cooperate a lot, especially on the e-waste management. If you go to the next, you found, okay, a little what is ITU, a very long terminology. Okay, we are working on different thematic like electromagnetic compatibility, human exposure to electromagnetic field. What is important is on circular economy and e-waste management, and all ICT related to environment, energy efficiency, green energy, and sustainable digitalization for climate action. We have a group that is called Question 7 that is work directly on e-waste, circular economy, and sustainable chain management to put together all of these three topics to advance on the climate change and the reduction, not reduction, reality, the correct management of e-waste. If you go to the next, we enter a little on what we are making. It's said in a lot of report, which is the urban mine. So the fact that if we are able to recover material from a waste, we can find a big number of material, like here is said that it's 20 kilo of gold from 1 million cell phone. And it is a very big quantity of material that we are able to recover. Unlikely from what Federico showed before, not all the material in the e-waste is actually recycled properly due to some problem of technology or some problem to have access to the good technology in all the place. In our standardization in the past, we wrote some standard. If you go to the next slide, one is this, that was wrote a lot of years ago, is L1010. All our recommendation is L and some number. That is a report on some procedure for recycling rare material in ICT technology product. In this standard, we define some recycling procedure for rare metal. We don't go in detail also because in 2012, the technology was very different respect to what is this, but we focus more on which are information that is necessary to give to the recycler to put them in a very good condition to recycle all the material. You see in the picture, okay, which type of material present. This is a very old mobile phone. But on the actual smartphone, I don't think that we have so many difference. And the idea is, okay, this is the process from the recycling to manage waste to arrive at the recovery of smart metal. But it's very important that for all the good, in some way, the information on how much rare material, which type of rare material, the quantity that are inside should be available directly, mean linked to the product, or at that time we think to manage by a designer authority, a third party. The first in reality is what is now going on with the digital product passport. So we, at that time, we think of something similar to digital product passport for the rare material to give this information to the people in charge of the recycling. If you go to the next, okay, thank you. This is the other standard that we wrote in 1101 that is dedicated to how to find the material that are inside the e-waste. And on this standard, we look on different methodology defined by IC that are available in the technology of the time. And we recommended two of these technology that are able to determine the type of material and also the quantity. That is what is important. It's not to know, okay, we only which are the material inside a product, but okay, how much material I have inside. And we said XRF for homogeneous material, homogeneous part, and ICP, MS for not homogeneous composition material. And this is something that can be done. The procedure to use this these two methodology is established. And there is one test case in appendix coming from a laboratory in Korea that apply these two methodology, one to the smartphone, the other to a video, to an LCD video, just as it was mentioned before. And here you have an example of the result of ICP analysis in a smartphone that you see which are the material that they found. This is more dedicated to this type of material. There is a lot of table. I don't report all different. I will never finish my slide. And the last point that is important is when we speak about recycle. I said that it's important to provide information on which type of material, the quantity of material which we have inside a product. But this don't mean that it's the final manufacturer only that need to take the responsibility. It's all the chain. So from raw material, from the production, from all the components inside the product need to have in some way information on which type of material, especially rare material, rare earth and similar material that are inside a component, a board, and so in a way that the final product can collect all this information and give this information to end-of-life treatment. Because if we speak about to recover all of this, it's important that the responsible for end-of-life have an information which material they can find inside the product. On this, I conclude this, and thank you very much for your attention. And okay, if you want to join us, our discussion will be on 3 of June in Geneva, just on the building near your building, where you are now. Thank you very much for your attention.
Thank you very much, Mr. Gemma, and we will indeed try to join you when you will be back in Geneva. So we are sadly running out of time. We have brought to you what is happening in various spaces, linking to indeed work happening in other ministries than the Ministry of Environment, all pushing for more sustainable use of our resources and showcasing of the amount of work ongoing in International Geneva to advance this agenda. And there is much more ongoing, and this is why we will be back with this series in various other spaces, including at the upcoming sessions of the Human Rights Council, and other opportunities that will emerge at the end of the year, and why not also when our colleagues of ITU meet here in Geneva. All the links of the various documents that were presented today will be made available on the webpage of this event. I encourage you also to have bilateral discussions as soon as we call this panel. I also want to mention that Mr. Payet was blocked in a meeting discussing a budget. That's why he was not able to join us at the opening of this event. So once more, I would like to thank everybody. I'm sad that we were not able to engage further with questions, but I hope that there will be much more bilateral discussions ongoing after this meeting. And I thank you all for joining us, and looking forward to have you in person or online at the upcoming sessions on this series. And once more, on behalf of Switzerland, Senegal, and the other UN institutions and NGOs and platforms convening this event, thank you very much for being with us today.